is Chantel, and for this ALDEC Riviera-PRO video, I will be going over the Makefile.tcl macro. This macro is an auxiliary utility used with the Make software development tool, and this particular script helps generate a makefile for your design to help manage dependencies and automate the compilation process. This is useful especially for large designs where compiling them in its entirety every time can be time-consuming. So using the generated makefile from using the Makefile.tcl macro can further boost the efficiency of the compilation process due to its ability to track dependencies between design resources and compile what's only necessary after changes. So I will be going over what you'll need to get the Makefile macro working. And from there, I will be using Riviera-PRO example designs to demonstrate the tool. And I'll be doing this in the GUI first, and then I'll demonstrate through batch mode. Now, here are the prerequisites you need in order to use the Makefile generator script. First things first is to make sure that Make is installed on your system. I'm going to check mine by going to the terminal and typing make --version. Once I've confirmed that, the next step is to run setenv, which is found in the etc. folder within the install location of Riviera-PRO. If you're launching the Riviera-PRO GUI through the desktop icon, you shouldn't have to worry about this step because the desktop icon utilizes the run GUI command, which already calls for setenv. From here, I can now open up Riviera-PRO. And once Riviera-PRO is opened, I'll need to source the Makefile.tcl before doing anything else. For brevity's sake, I just have a quick little copy-paste text file here, and this is the path of the Makefile.tcl that I'll source. It will always be in the Riviera-PRO scripts ALDEC makefile path. So with Riviera-PRO opened and the makefile sourced, let's go ahead and get our generated makefile. First, know that the makefile for the design can only be generated after an initial successful initialization of the simulation. This is necessary because the procedure that we'll be using will need this to analyze the dependencies between the resources of the design. The example I'll be using is called filter, which can be found in the mixed language subdirectory of Riviera-PRO's examples folder. I chose this because I want to show how the makefile generator supports compilation of Verilog, VHDL, and EDIF files. I'll now go to the filter example, and it's runme.do script. Now, I also want to demonstrate that enabling code coverage can be generated in the script. So in this runme, I'll add a statement and branch coverage to each compilation command that has the debug argument. From here, I'm going to highlight and select up to the asym command and click on execute selection. See now that the compilation was successful and simulation has been initialized. Now all that needs to be done is to run a procedure in the console called ALDEC makefile generate. This is a case-sensitive procedure, so be sure to type this exactly as shown. Once I hit enter, the console shows that the makefile was successfully generated. And with that, I can now end the simulation. When I type pwd in the console, it shows that I am working in the main directory of the filter example design. And in the file system, you'll see that the makefile was generated here. Now, let's take a look at what was generated. You'll notice that there are compilation arguments generated for the VHDL and Verilog sources. The debug and even the coverage argument I added are here. reflecting the commands used for compiling from that script. Then there are variable assignments for the libraries that were used for compilation, which are the IEEE and standard library. Next, you'll see that there are a number of rules generated that represent the design's dependency chain. For example, you'll see that when you use makeAll, it depends on the filter functional TB. And that test bench relies on the top-level design called filter, and filter depends on the other files, and so on. Below these are the rules for compiling each source type. Basically, it shows that in order to build, you'll need to compile these files along with their compilation arguments. After this is the rule to create the working library without initializing compilation. And last but not least, we have the clean rule in order to clean the compiled libraries. So, whenever you run that ALDEC makefile generate procedure, you'll get a generated makefile looking something like this. I'll go ahead and run some make commands to show the makefile in action. First, I'll clear the library so we can do a fresh compile. So I'll type make clean. And now notice that the filter library is gone. I'll go ahead and compile everything once more by just running makeAll. You'll see in the console log that the filter library gets created, and then the source files get compiled in order based on the dependency chain. And it looks like everything compiled with no issues. So now if I try to run makeAll again, it shows that nothing needs to be done for all. And if I target a specific source, like make filter/filter, it'll show that it is up to date. And let's say that I decide to edit the OSL source file, and I'll just put a new register called foo in there. Now I'll save it, and let's use another make command again. Notice in the make file that filter is dependent on this file. So I'll just use make filter/filter again. And now see that out of all the files that filter depends on, only OSL is compiled, followed by filter itself. So that's basically how you use the makefile_tcl macro to generate a makefile for your design. Now I'll show how to use this through terminal or batch mode. So once again, the first thing you need to do is to execute the set_env file first. So in my terminal, I'll run it there. And instead of launching the GUI, I just open up batch mode by typing in vsimsa. Once batch mode is working, I'll once again source the makefile_tcl script. Now I'll navigate over to another example design called datapath that's located in the VHDL subdirectory of the examples folder. Once in there, I'll go into the source folder and run the runme.do macro for this design only up to the point of initializing simulation. For reference, I would run this starting from the first line all the way up to line 24. So for this case, I will use the command do with the argument -end, followed by the line number 24, and lastly, runme.do. Now the terminal shows that the simulation has successfully been initialized. And now, like last time, I will use the procedure ALDEC makefile generate, and the makefile is created. I'll end sim, and when I type ls, you can see that the makefile now exists, and I can run make commands like make clean and then make all. So this is what it looks like to run the makefile generator macro in batch mode. But one more thing I'd like to share is that you can make edits to this makefile to include your own rule where you can run a simulation. I'll open up the datapath makefile, and I'll make a rule called runSim. With this rule, I'm going to include it in phony, and then I'll use the simulation command vsim. With this command, I'm going to pass the argument -c and then -do, followed by the macro name sim_run.do. This will run the simulation macro in batch mode. As for this simulation macro, let me show you what's in it. I have it within the datapath's main directory, and in this macro, the library datapath is attached, a global library called worklib is set, and then that worklib is set to the datapath library. The next command will be vsim, and simulation gets initialized with the top level name, top testbench. I'll also want to log the signals of the design so I can look at the simulation results afterwards. So the log command is here with the -recursive argument, followed by the * wildcard to basically get data from all the signals. And lastly, in the macro, simulation is run all the way through, ending with endsim. I'll go back to the terminal, and I'll now go ahead and use the new make runSim. And there it is. I was able to run the simulation macro where it attached the datapath library, initialized my simulation, and ran it to the end. And when I go back to the Riviera-PRO GUI and open the datapath simulation dataset file, I can open up a waveform view, then click and drag the simulation dataset into the waveform, and I get my results from the simulation that I ran in batch mode, but now in this waveform format. And there you have it on the makefile generator. As you can see, having a makefile for your design makes the compilation step easier thanks to the makefile's innate ability to track dependencies between design resources, while potentially reducing compilation time when you need to make edits to your HDL sources. Being able to also add in your own makefile rules after generating the makefile, like for running simulation, is just icing on the cake. No matter the size of the design, the makefile.tcl macro is there to help make compilation more efficient. Thank you for watching.